During many contacts, you might say that you're running X number of watts. Well, how do you know that? Let's find out.
Whiskey 6 Lima calling CQ, hello CQ. CQ calling CQ, hello CQ. Whiskey 6 Lima Golf. Whiskey 6 Lima.
Hi, I'm Jim, W6LG for Ham Radio Basics. Welcome to my radio room here on Wolf Mountain. I put together, cabled together, a bunch of watt meters and SWR meters. Some sort of slow to indicate, others pretty fast. For example, on the top left corner is the Array Solutions Power Master. Let's see. Not only a watt meter, but it's also an SWR meter. To the right of that is the LP100A from N8LP. Again, another device that indicates power out and the SWR. Below that are three Drake watt meters. The one on the left is in an MN2000 antenna tuner, also happens to have an SWR function. And I'm going to use the watt meter to the right, the W4. It's set in the 200 watt scale. Below that and on the left is the Elecraft K3. It also has a built-in watt meter and SWR meter. To the right of that is the Elecraft P3. And that one does have a peak reading watt meter and SWR meter. To the right of that is the Elecraft KPA 500. So that's my linear amplifier to generate a couple of hundred watts. It has a built-in power meter, watt meter, and SWR meter. Also has ramping LED scales for tuning. Above that is the KAT 500, which also has a built-in watt meter, but it's rather SWR meter, but it's not all that accurate. Let's do some tests, and this is going to be part one of a two-part video on SWR and watt meters. So let's see what happens when we transmit with 100 watts with a carrier, 100 watts two-tone, 100 watts into a high SWR greater than 3 to 1, and then we'll do the same thing again at 500 watts and see what the differences are on the meters. Will they all read the same because they're all good meters, or will there be some variation? And to give you a clue as to what I've done behind all of that, I've hooked up lengths of coax. So they are in different locations in the feed line. So let's see what happens. I'm going to start the video now and we'll go from there. Set at about 200 watts. That one says 198, 189, 190, 192, 197, 190 roughly, 210. So they're all, and that one's reading 130. All right, let's go to a single tone. In fact, let's raise the SWR. So I'm going to change out the antenna tuner. Now it's got a 3 to 1 SWR, 3.5 to 1. It says 140, 130. It's changing just a bit. That one says 150. That one says 150. That one says 80 watts. And that one says 70 watts. And that's with a fairly high SWR. So why is that? Why is there the big difference? That one says 2 to 1, 2.0 to 1, and that one says 3 to 1. That one says 3.4 to 1. That one says 2.4 to 1. What's the difference? All right, let's do a single tone. With lower power. 3, about 70 watts, 67 watts, close enough. That one says 95 with a 2.4 to 1 SWR. That one says, again, says 2 to 1. The antenna tuner's out of the circuit. And that says 80 watts. So what gives? Why is it doing that? And let's ramp up the power a bit. Okay. That one says 150 watts now. That says 123. That one says 111. That one says 175. That one says 170. That one says 140. 3.4, 3.7, 2.5, and 2.2 to 1. So why the big difference? What's going on here? All right, let's go back to matching. Okay, there's about 1.2 to 1, 1.1 to 1. Even better there. All right. So now I've got a pretty good match. 100 watts, 103 watts, so 120 watts, 160 watts, 114 watts, 90 watts. This one says about 95 watts. SWR here is about 1.1 to 1. So with a good match, they pretty much show the same SWR. 1.1 to 1. That one I'm not going to mess with. 1.2 to 1, 1.2 to 1, 1.1 to 1. But what happens when we have a mismatch? Okay, now we've got a huge mismatch. 3.2, 3.4, 71 watts, 66 watts, 95 watts, 2.4 to 1, 2.2 to 1 over here, and 80 watts. So those are reading roughly the same. But the SWR is 3, 3, 2 over here, and 2 over here. And the transceiver is seeing a 1-to-1 SWR. So what's going on here? Why the big change? And this antenna tuner is saying greater than 2 to 1. So let's run up the power just a bit. All right. There's 200 watts. So that says 180. That says 160. Notice the SWR is now reading almost 4 to 1. 2.7 to 1, 257 watts. 257 watts versus 160, 180. This, oh, it got too hot. All right. Let's turn that off. Stressing it out too much. 1, 2, 3. All right, there's 200 watts. 1, 2, 3, 4, 5. That one's indicating about 10 watts, maybe less. That one also about 10 watts, maybe less. The scope down here is indicating 180 or so. Linear is indicating about 180, 190. So let's talk that up just a bit. Okay, 1, 2, 3, 4, 5. We're into the light bulb. 1, 2, 3, 4, 5. All right, we're into the light bulb at about 200 watts. The analog meters are indicating about 10 to maybe 20 watts on peaks, but mostly around 10 watts. The digital meters are indicating 180 to 200 down below, out of range. This one's also showing maybe 20 watts on peaks. So 20 watts here, 200 watts here. So what's the difference? Well, there's a lot. Look at the light bulb and how it glows. The light bulb takes a bit to heat up, and so does the meter. So as you transmit, you can see if I transmit a tone, it's going to get white hot. If I'm just speaking into it, it's sort of orange. So let's do a tone. All right, there we go. Okay, so if I'm the correlation between the light bulb and the meters is a bit of a stretch, but what I'm saying is it takes a while for the bulb to react, and it takes a while for the meters to react. So even though I'm running 200 watts, which is full scale here, this is indicating occasionally 20 watts. That one, it's about the same. It occasionally hits 20. Where in fact, I'm occasionally over 200 watts. So let's increase the output. Okay, that's well, let's see, that's 300 watts. Let's increase the output. And 1, 2, 3, 4, 5. Roughly 500 watts on voice peaks. And the digital meters are having a tough time coping with the change in the load because the SWR is high. Let's put the tuner back in the circuit. All right, there now these meters are indicating 500 watts. Okay, these digital meters are indicating upwards of 500 watts on voice peaks, and that one just said 600. The analog meters are indicating about 60 watts or so. In this case, in this freeze frame, the two digital meters are showing different wattage readings. One has 504, the other one 595. The difference there is just in the way the two devices sample and how quickly they can get something up on the screen. Eventually, they showed the same power within a few watts of each other. The analog meters for complex waveforms typically showed about, in the SSB mode, speaking into the microphone, they were typically showing about 10% of what the peak power probably was. In this freeze frame, the two analog meters are indicating about 50 to 60 watts. The digital meters are indicating 500 to 600 watts. Key down single tone. There were some differences, and I'll explain that in just a bit. The two-tone oscillator, where I keyed it for a long period of time, just as a rule of thumb, they're probably going to indicate about 70% of the peak power. And again, these are heavily damped Drake meters, so they're quite slow, and that's, again, something to keep in mind when you're tuning up or using, let's say you're running a linear amplifier and you're looking at the play current meter, and the play current meter is indicating 100 mils. It's likely to be a whole lot greater than 100 mils because the meter is slow, just like those light bulbs and the meters in this picture, to get there. So keep that in mind, that if your play current meter is showing 100 mils, just for example, it may actually be 500 mils of play current. And if you've tuned up the amplifier for 400 mils peak play current, but you're actually peaking 500 mils of peak play current, what's happening? Well, probably splatter, distortion, and other things. And you may not be aware of it. In your headphones, which are sampling in the transceiver at one of the audio stages, it sounds fine. What's coming out of the coax connector on the back of the linear amplifier may be something very different. All right. If you've enjoyed this video, and I hope you have, please do subscribe. I'm trying to get as many subscribers in this year as I can. If you have a question or a comment, and I think this is one that's going to generate lots of comments, put it below. I think this is kind of a fun one. Everything is fair game here. What do you think was going on? And again, to re-emphasize, I was using different lengths of coax, and these meters are in different places on the feed line. And that makes a big difference in what they see. To that point, I'm going to take the Power Master on the left and connect it to an antenna where I can vary the impedance. And the LP100, I'm going to use its sampling box and put it in different places in the feed line. And we're going to do that in the next video. And we're going to see what the SWR is when they're both in the same place. And what happens when the sample box is, let's say, 50, 60 feet down the line, or 20 feet, or maybe 100 feet. I've got a lot of RG8X I can use to do that, and also how much loss is there, and how much. At one point, the losses may make the SWR look really good when in fact it's not. All right, that's the next video. Thanks for watching. I'm Jim, W6LG for Ham Radio Basics. See you on the next one.